So hello everyone. So in this lecture we will go through the assembler, and here we will study about the database or data structure used, the format of the data structure, and the algorithms for pass 1 and pass 2. So this is our lecture outline where we will go through the data structure for pass 1, then pass 2, then format of the database, then algorithms. So here you see the database for pass 1. Okay, pass 1 is nothing but a algorithm, or it is a step, or it is a phase where the source program is inputted. Okay, after the source program is inputted, it just the main function is to define the symbols, the literals, or anything defined in the form of the format, length, length of the instruction or format of the instruction, like that. Okay, so we have to define. So the first one is input source program, then location counter is there, then machine operation table is there, pseudo operation table is there, symbol table is there, literal table is there, a copy of input to be used by pass 2. So these are all the databases of pass 1. Here the symbol table, the tables itself are used to define the instruction. So after by seeing the tables, we can define a symbol. Suppose load is a instruction, it is coming, so it is of 4 byte, the length is 4 byte. We can see it is hexadecimal, the representation of load. We can see the machine code of means 01 code of load. So by this we can know. So we have to define that load in pass 1. So these are the databases used. So for database 2 means generating the code after defining, this is done by the following databases. So here copy of source program input to pass 1 is used. Okay, the program after in pass 1 which is passed through, it is pass 2 now, pass 2. Then location counter, MOT, POT, ST, base table BT, a workspace INST, a workspace print line, a workspace punch card, and output DAC of assembled instructions. Okay, here two terms are there, one is DAC and one is card. So card is a program and DAC is the collection of the instructions. Okay, so these are the databases used for pass 2 to generate the object code. Okay, so here the format of the database we can see. So in Donovan you can go through the Donovan, you will easily understand by seeing these tables. Okay, here the format is given like hexadecimal format or the machine code format, like that, or binary format is given for an instruction. Suppose AAA is a mnemonic. Okay, to binary, here binary code is also given, then instruction length is also given 10. Okay, then instruction format is also given, like that. It is a machine opcode table. Okay, from the instruction we can see what is the length, what is the hexadecimal format, okay, what is the instruction format, we can see from here. Okay, so we have to define this like that. In pseudo opcode table we can see, suppose start is there. I've told in the previous lectures that pseudo opcodes are like start using predefined terms, like ending a program, starting a program, like that. Okay, it is not machine opcode. So here it is of 8 bytes. Okay, here you can see the pseudo op. Okay, and then address of routine to process pseudo op. So you can refer Donovan and you can easily get this. Okay, so here the symbol table is there. For example, symbol are of 8 bytes. Okay, we can reprint the whole symbol in 14 bytes per entry. Okay, value hexadecimal 4 bytes, 1 byte the length, then relocation 1 byte. Okay, like that. Now we will go through the algorithms. So before going through the algorithms, okay, you refer to Donovan and you will get the flowchart. Okay, by seeing the flowchart you can go through these steps. Okay, and you can easily understand the algorithm for pass 1, means how an instruction is defined in pass 1. So the first step is initially the location counter points to the first location of the program, then a source statement is read, then operation code field is examined whether it is pseudo op or machine op to find a match for the instruction length. Means both are different things, pseudo opcodes and machine opcodes. I have told earlier, okay, in the previous lectures. Then the operand field is scanned for presence of literal. If a new literal is found, it is entered into the literal table. Okay. The label field of the source statement is then examined for the presence of a symbol. Okay. Then the seventh point here, we have it is 7th, then 8th, then 9th. Okay. It is some error is there here, but you rectify it. If there is a label, the symbol is saved in a symbol table. Finally, the current value of the location counter is incremented by the length of instruction, and a copy of source code is saved for use by pass2. Okay. The above sequence is repeated for the next instruction. Means for a single instruction we have to repeat these 8 steps. Okay. And this process continues for every instruction. Then algorithm 2 means after that you will get a object program which is then passed to the second phase, that is pass2. Here the steps are: 1. A card is read from source file left by pass1. Okay, you understand this. If it is a pseudo op, then end. Else search machine opcode table, get instruction length, type and binary code. Evaluate operand expressions by searching for values or of symbols. Assemble together the parts of the instructions. If a listing line containing a copy of the source card, its assigned location and its hexadecimal representation is then printed. Finally, the location counter is updated to process the next card. So from this phase 2, after converting each instruction into a object code, all are assembled together. Okay, all are assembled together and we can make a object program. Okay, so in this lecture we have studied about the passes, the data structures, the databases, the formats of the databases, algorithms of assembler. Thank you.